Ma'am.
Good evening, boys.
Ma'am, when we are going to start, ma'am. Good evening, ma'am. Good evening, ma'am.
Children, no questions now. We are starting with the session. All your questions will be answered at the end of the session. All right. Good evening, boys.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Good evening. Integers is the first chapter in your NCERT math textbook. And that's the chapter we are going to get started with for 7th standard. Is my presentation visible? I've shared my presentation. Is it visible?
Yes, ma'am. Yeah, ma'am.
Okay. All right. So to start with this chapter, we need to recall the meaning of these terms, natural numbers and whole numbers. Okay. So what are natural numbers? Counting numbers are called natural numbers. Now, what do we mean by that? Counting numbers. Now, supposing there are some articles lying on a table. Okay, on the table you find some articles. There are some articles lying on a table. So how do we start counting these articles? We say 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 articles lying on the table. So these counting numbers are called natural numbers. See, you will not count like minus 10, 5, whatever, 6, 3, minus 2. You don't count like that. How do you count? To count, you start from 1, 2, 3, and you go on like that. So counting numbers are called natural numbers. And N is the letter. Capital letter N represents natural numbers. Capital letter N represents natural numbers. And excuse me, children, I'm getting a call. Just a minute.
Yeah, ma'am.
Yeah, children, I'm back. So natural numbers are represented by the capital letter N. And how do you show all the natural numbers here? Capital letter N is equal to, open a flower bracket. This is called a flower bracket. Open a flower bracket, 1, 2, 3, 4, and it goes on like this. Okay, and close the flower bracket. So we see that the smallest natural number is 1. But we do not know the largest natural number. The greatest natural number we cannot say, but the smallest natural number is 1. That's about natural numbers. Now whole numbers. Natural numbers including 0 form the collection of whole numbers. So whole numbers are represented by the capital letter W. So W is equal to, open a flower bracket, 0, 1, 2, 3, 4, and it goes on like that. So the smallest whole number is 0. The greatest whole number you cannot say because it goes on. The collection goes on to infinity. So you cannot say the greatest whole number. Now comes integers. What are integers? All natural numbers, they're negatives. What do we mean by negatives? Listen carefully. Now, natural numbers are 1, 2, 3, 4, and so on. They're negatives. The negative of 1 is minus 1. The negative of 2 is minus 2. The negative of 3 is minus 3. The negative of 4 is minus 4. It goes on like that. Okay. Including 0, form the collection of whole integers. Form the collection of integers. So see here, all natural numbers, they're negatives, including 0, form the collection of integers. I'll repeat, see here, 1, 2, 3, 4, 5, this collection goes on. This is the collection of natural numbers. Now they're negatives. -1, -2, -3, -4. This collection also goes on. Okay, including 0. So the collection of all natural numbers, their negatives, including 0, form the collection of integers. So if you're asked, if I ask you a question, is this an integer? Okay, I give you a number and I ask you if it is an integer. So you should ask yourself 3 questions. If I give you a particular number and ask you if it is an integer, then you must ask yourself 3 questions. Is that number a natural number? Is that number the negative of a natural number? Or is that number 0? If you get yes for any one of these 3 questions, then it's an integer. If it's a natural number, it is an integer. Or if it is the negative of a natural number, it is an integer. If it is 0, it is an integer. If it is anything other than these 3, it is not an integer. Now, what that can be, you will see next year. Okay, they are called rational numbers. We'll see them next year. So if I give you a number, if I give you a number and ask you if it is an integer, ask yourself 3 questions. Is that number a natural number? If it is a natural number, it is an integer. Okay, if it is not a natural number, your second question will be, is it the negative of a natural number? Okay, so for that also, if you get the answer no, then the third question will be, is it 0? If that is also no, if all the 3 questions have the answer no, it is not a natural number, it is not the negative of a natural number, it is not 0, that means it is not an integer. If it is an integer, it will be any one of these 3. It will either be a natural number, or it will be the negative of a natural number, or it will be 0. It will be any one of these 3. If it is not any of these 3, it is not an integer. Then what is that number? That is a rational number. You will see that next year. We'll not go to that now. So these are the 3 questions you should ask yourself if you have to judge if a number is an integer. So see the collection here. Integers are represented by the capital letter I or Z. The capital letter I or Z represents integers. And how do you represent the collection? See here, because you do not know the smallest integer. The smallest integer we cannot say. It begins from nowhere. We don't know the smallest integer. And then -4, -3, -2, -1, 0, 1, 2, 3, 4. And again, it goes on like this. So you cannot say the smallest integer nor the greatest integer. Okay, you cannot identify the smallest integer, nor can you identify the largest integer. But when it comes to natural numbers and whole numbers, you know that the smallest natural number is 1 and the smallest whole number is 0. But the greatest natural number can't say, whole number can't say. When it comes to integers, you cannot identify both the smallest and the largest integer. Is that clear, children? Please acknowledge.
Yes, ma'am. Sorry, Yes, ma'am.
All right, children. Very good. So now that's about integers. That is about integers. Now you can see the note below. Natural numbers and whole numbers are integers. Every natural number is an integer. Yeah, because in the collection of integers, we have natural numbers. See here, we have natural numbers. Every natural number is an integer. Every whole number, see here, we have the collection of whole numbers here, 0, 1, 2, 3, 4. Every whole number is an integer. Every whole number is an integer. Okay, so in the collection of integers, what do we have? We have all whole numbers and the negatives of the natural numbers. In the collection of integers, what do we have? We have all the whole numbers. From here, we have all whole numbers and the negatives of the natural numbers. So that is the definition of an integer. The collection, not collective, sorry, the collection of all natural numbers, the negatives of all natural numbers, and 0 form the collection of integers. Is this slide understood, children?
Yes, ma'am.
Okay. So now what you have to do is,
Yes, ma'am.
you're not going to write anything now in the class. In the class, you're just going to listen to me. Now take a screenshot. All this is your homework. You'll have to complete all this before the next class. Give the heading integers. This is 7th standard, grade 7. This is not 6th standard. Okay. Integers is the name of the chapter, the first chapter. Take a screenshot of this one and write out all this in your tuition notebook. When you come to the physical class, I'll see. It should be written neatly. Take a screenshot, all of you.
Yeah, ma'am.
Can all of you
This
capture?
full page.
Can all of you capture a screenshot on your device?
Yes, ma'am.
Okay.
Ma'am, I can't do, ma'am.
Can you ask Anirudh, your friend, to share it with you then?
Yes, ma'am.
Anirudh, can you share the pictures with him?
Yes, ma'am. I will share, ma'am.
Okay. All right. Next is about the properties of integers. Okay, so under properties of integers, we will be visiting the closure property of integers, the commutative property or commutativity, associative property or associativity, distributive property or distributivity. We will be seeing all these properties of integers: closure property, commutative property or commutativity, associative property or associativity, distributive property or distributivity. Okay, now what do we mean by the closure property of integers? That's what we're going to see here. Okay, now I'll explain what is in the slide. Listen carefully. Okay, so this is, let us revisit. I don't know if you have learned this in standard 6. You should have learned it in standard 6, but I'm not very sure. So that is why I've given the heading, let us revisit. Okay, but if you're seeing it for the first time, it's okay. I will be telling you in detail. Okay, the closure property for all the operations on integers in brief. Okay, now we are going to consider only integers. Okay, we are going to consider only integers. We're going to use all the operations and check the closure property for integers. We're going to check the closure property for integers using all the operations. Okay, now let me begin with what we understand by the closure property of addition of integers. Closure property of addition of integers. See, the property is closure. The operation is addition. And the numbers are what we are going to test this on integers. We're going to check this on integers. See, like we have natural numbers, we have whole numbers, we have integers. So we're going to check the closure property on integers. For which operation? Addition. Okay. Now, integers are said to be closed under addition. You can see here. Integers are closed under addition. That means the sum of two integers is always an integer. That's the meaning. The sum of two integers is always an integer. Now let's consider two integers, say -4 and +3. Okay, -4 and okay, let me put it like this for you. -4 is an integer and say -7 is an integer. We're going to add these two integers. We're going to add these two integers. What is the result, children? What is -4 plus -7?
-12, ma'am.
Same signs, no? Same signs. So we'll have to add 7 plus 4 is 11 and put the same sign.
-11.
Yes. -11.
-11.
See, if you don't understand these operations, I'll be telling you. Now, we're just trying to understand the property. Once we start working the sums, I will explain all this again. When to add, when to subtract, which sign to put. We'll see that in detail. So now if you feel you have forgotten how -4 plus -7 is -11, don't worry now. Okay, I'll do that in the next session when we start the problems based on integers. So see here, I've taken one integer. This is another integer. The sum of two integers is also an integer. That means integers are closed under addition. Now subtraction. When you take two integers and find their difference, okay, when you find their difference, take any two integers. You don't have to take -4 and -7. I'm just taking the same two numbers. When you take two integers and find their difference, the difference is also an integer. Okay, so how do you simplify this? It will be -4, minus into minus is plus 7, and the answer is 3. Because different signs, so we have to subtract 7 and 4. When you subtract, you get 3 and put the sign of the greater number. So plus 3. And 3 is also an integer. See here, -4 is an integer, -7 is an integer. When you find the difference of two integers, what is the answer? 3. And that is also an integer. That means integers are closed under subtraction. Similarly, when we yeah, tell me.
Ma'am, how ma'am it will come -3 ma'am instead of -3?
That's what. So see, this part only I was telling you. I will be telling you this in detail. This you should have learned in 6th standard, but there are chances that children forget it. It's okay. It's natural to forget. I told you I will tell you these properties in detail when I start the problems, when we work problems on integers. So don't worry, Anirudh, okay? I'll try to tell you, but I'll try to tell you, just see if you can understand. -4 minus -7. First, you'll have to multiply the signs, minus into minus plus, okay? So it will be -4 plus 7. Now there are the two numbers have different signs. So you have to subtract 3. And the greater number is 7 and its sign is plus. So put the sign of the greater number, which is plus 3. Yeah.
Ma'am, we should always multiply these operations. Minus into minus, plus division, multiplication into multiplication, like that.
Correct. If you have to open the bracket, you'll have to multiply the signs. To remove this bracket, you have to multiply the signs.
Ma'am, if there are no brackets in this sum, we can do like -3.
Yeah, see, there is a bracket because you cannot write -4 minus -7. When there are two signs like this, there will be a bracket.
Ma'am, when it is like this, we should multiply signs, ma'am.
Correct. You should multiply the signs. Don't worry, we'll learn all this in detail. Okay. Next, multiplication. Now, when you multiply two integers, say -3 into -7. Okay, when you multiply two integers, -3 is an integer, -7 is an integer. When you multiply two integers, 3 7s are 21, minus into minus plus. Again, children, if you don't understand this, it's okay. But see here, the product of two integers is also an integer. 21 is an integer. Now, the quotient of two integers, meaning when you consider two integers and divide one by the other. Now, integers are closed under division, but not always. So since they are not always closed under division, we say that not always closed, meaning sometimes you will get integer as an answer. Now, for example, 10 is an integer and 5 is an integer. When you divide 10 by 5, you get 2. 2 is an integer. But when you divide 5 by 10, 5 is an integer, 10 is an integer. When you divide 5 by 10, you get 1 by 2. But 1 by 2 is not an integer because 1 by 2 is not a natural number. 1 by 2 is not the negative of a natural number. 1 by 2 is not 0. So it is not an integer. How do you check if a number is an integer? It should be a natural number. 1 by 2 is not a natural number. Then it should be, if it is not a natural number, how can it be the negative of a natural number? It is not a natural number at all. Then how can it be the negative of a natural number? So if it is not a natural number, it is not the negative also of a natural number. And it is not 0 also. That means it's not an integer. So you can see here, 5 divided by 10. When you simplify, 5 ones are 5 twos are. 1 by 2 is not an integer. So you can see here, when you divide an integer by another integer, the result is not an integer. Sometimes it's an integer. See, now when you divide 15 by 3, you'll get 5. 15 is an integer. 3 is an integer. When you divide 15 by 3, you get 5, which is also an integer. So when you divide an integer by another integer, the result may be an integer, may not be an integer. It depends. Sometimes it's an integer, sometimes it's not an integer.
Ma'am, is it depending on the question?
Yeah, correct. It depends on the two numbers you consider. It depends on the numerator and the denominator. So since when you divide an integer by another integer, the result may or may not be an integer. That is why we say integers are not closed under division. So this is what is the closure property. Closure property. So I'll tell you again, when we consider two integers, the sum of these two integers will always be an integer. Take any two integers and find their sum. That result will be an integer. Always it will be an integer. This means integers are closed under addition. Next, take any two integers and find their difference. That answer which you get no will always be an integer, always be an integer. That means integers are closed under subtraction. Again, take any two integers and find their product, meaning multiply them. The result is always an integer. That means integers are closed under multiplication. But when it comes to division, you know that 100 is an integer. You know that 200 is also an integer. But when you divide 100 by 200, 100 is an integer. 200 is also an integer. When you divide this integer by integer, we get 1 by 2. The result is 1 by 2. 1 by 2 is not an integer. This means integers are not closed under division. Do we understand that?
Yes, ma'am.
Yes, ma'am.
All of you?
Yes, ma'am.
Ma'am, Darshan actually left the meet.
Okay, maybe he can use the recording. I don't know. Okay, fine. Probably he has some internet issues. Okay, all of you take a screenshot of this one. Children, make sure that your device has captured the screenshot. Please do not request me to send all this. Take it now and check it if your device has captured the screenshot.
Yes, ma'am. Yes, ma'am.
All of you?
Ma'am, we want to write the properties of integers also, no, ma'am. We didn't take screenshot on that.
Oh, very good, very good. Ah, very nice, Anirudh. Very good, very good. Yes, yes. Take a picture. This is the first one, and after that is this one. Write it in the correct order. Thank you, Anirudh.
Ma'am, Avanish, ma'am.
Oh, Avanish. Okay, Avanish, thank you, thank you. Thank you, Avanish.
Okay, ma'am.
Yeah. This is the second slide. This is the next one. Done, children?
Yeah, ma'am.
Okay. This is the next one. This is
Ma'am,
the
no, ma'am. Wait, ma'am. 1 minute, ma'am. Ma'am, please, ma'am. 1 minute, ma'am. Ma'am, 1 minute. Show that, ma'am.
Oh.
Ma'am, took, ma'am. Yeah, ma'am.
All right. Now we're going to learn about the commutative property for all the operations on integers. Okay. Commutative property. All operations integers. Integers, that's what we're doing now. Integers, all the operations plus addition, subtraction, multiplication, and division. And we're going to check the commutative property. What is this commutative property? Okay. So now when you consider two integers, say 3 and 4. Okay. So 3 plus 4 is the same as 4 plus 3. That is A plus B is the same as B plus A. If A is an integer and B is an integer, A plus B is equal to B plus A. If A is an integer and B is an integer, then A plus B is the same as B plus A always. Always. 3 plus 4 is 7, 4 plus 3 is 7. Always. You take any two integers. You take any two integers. Okay, so if in general, when you take two integers A and B, A plus B is the same as B plus A. Therefore, we say that addition is commutative on integers. On integers, you can write on integers. Addition is commutative on integers. Subtraction. Now, subtraction is commutative or not? Because it's not commutative because you will not get the same answer. Now, see here, if you take 3, again, we'll take the same examples. We'll take the same examples. Now, when say the first integer is 3 and the second one is 4. Okay, so 3 minus 4. Is it the same as 4 minus 3? That is A minus B the same as B minus A?
No, ma'am, no.
No. No. Since A minus B is not the same as, because 3 minus 4 is minus 1, but 4 minus 3 is 1. So you don't get the same answer. See, the answer is an integer. That is not what we are checking here. Now, don't say in both the cases we are getting integers. No, not that. In both the cases, you must get the same answer. That is what is the commutative property. When you perform A minus B and B minus A, you must get the same answer in both. Not that you should get integer. You should get the same integer. Now, if you consider, say, 9 and 20, 9 and 20, 9 minus 20, A minus B and B minus A, 20 minus 9. Are they the same? 9 minus 20 and 20 minus 9, are they the same? No. What is 9 minus 20? It's minus 11. What's 20 minus 9? It's 11. This is a negative 11. There's a positive 11. There's a negative 11. There's a positive 11. So, since A minus B is not equal to B minus A, we say that subtraction is not commutative on integers. Subtraction is not commutative on integers because if A is an integer and B is an integer, A minus B is not the same as B minus A. Is that fine, children? Next, multiplication. When you take two integers, so like 4 and 5, 4 and 5, 4 into 5 is the same as 5 into 4. Or if you multiply minus 3 and minus 9, it will be the same as minus 9 into minus 3. Am I audible, children?
Yes, ma'am.
Okay. So when you take two integers and find their product, so if you consider the integers 4 and 5, 4 into 5 is the same as 5 into 4. Or minus 3 into minus 9, that answer is the same as the answer you get for minus 9 into minus 3. It's 27 in both the cases. Minus into minus plus, 9 3s are 27. Minus into minus plus, 9 3s are 27. So we say that multiplication is commutative on integers. Division is not commutative again. Because you should get the same answer. Like when you do 10 by 5, what do you get? You get 2. But when you do 5 by 10, you get 1 by 2. That is A minus B should be the same as B by A. Sorry, not A minus B. A by B should be the same as B by A. When you do A by B, so supposing you take the integers 10 and 5. Okay, so 10 divided by 5. This answer should be the same as 5 divided by 10. That is A by B should be the same as B by A. If it is equal, it is commutative. Division is commutative. But it's not, no? Because when you do 10 by 5, you get 2. But when you do 5 by 10, you get 1 by 2.
1 by 2, 1 by 2.
So division is not commutative on integers. Division is not commutative on integers. So if A and B are two integers, A plus B is equal to B plus A. So we say that addition is commutative on integers. If A and B are two integers, A minus B is not the same as B minus A. So subtraction is not commutative on integers. If A and B are two integers, A into B is always equal to B into A, which means multiplication is commutative on integers. When you take two integers A and B, A by B is not always equal to B by A, which means division is not commutative on integers. Is this understood, children?
Yes, ma'am.
1 minute, 1 minute.
Yes, ma'am.
Yeah. 1 minute. Yeah. Take a picture of this one. Children, now let me see if Darshan is back. Yeah. Darshan, what happened? You were not in the meeting for some time.
Ma'am, network issue, ma'am.
Okay. Okay.
Ma'am, I have a doubt, ma'am.
Yeah.
Ma'am, you have told us to take a screenshot. In the numbers, what we must write?
Any example of your choice?
Okay, ma'am. Thank you, ma'am.
Any one example of your choice?
Okay, ma'am.
Yeah. Now, after the slide, after the slide, you need to write this. Let me just come again from the beginning. This is the first slide, children. Okay. This is the second slide. Properties of integers. Okay. Then this is the third slide, closure property. Then after this, I did not show you this slide. I went to the next one. This is the third slide. I'm sorry, this is the next slide. You have not taken a picture of this. Take a picture of this. Done?
Yes, ma'am.
Now this one, what we just discussed, commutative property. We finished this. And this is the description for the commutative property. Take a picture of this one.
Good, ma'am.
Ma'am, I took it.
Yeah. I'll let you. This is the next one. Associative property. Okay. Associative property for all operations on integers. Associative property. Now, the meaning of the word associative, association is group. Association means group. So for commutative property, we take only 2 numbers. For associative property, we take 3 numbers. 3 numbers. Associative property, 3 numbers. Okay. Now, when you take 3 numbers meaning 3 integers A, B, and C. Okay. When you consider 3 integers A, B, and C, A plus B plus C is the same as A plus B plus C. That is, here you're grouping B and C. Here you're grouping A and B. But in whatever way you find the sum, the result is the same in both the cases. If A, B, and C are 3 different integers, then A plus B plus C will be the same as A plus B plus C. So we say that addition is associative on integers. Addition is associative on integers. You have the description here, children, so don't worry about it. You have the description here. Next, if A, B, and C are 3 integers, then A minus B minus C is not the same as A minus B minus C. Now, these, when we take up the problems, the numerical situations, you will understand, you will see these properties there. So don't think like it's so theoretical, she's not giving example. So when we go to the exercise and solve sums, there I'll be telling you. There we will be understanding better. Okay, so now just understand how much ever possible. All this will be more clear when we work out the sums. So when A, B, C are 3 integers, A minus B minus C is not the same as A minus B minus C. So what is that we are doing? See here, children, it's very easy. I'll write it for you. See here, write A plus B plus C. is equal to A plus B plus C. Can you write this? Can you write this, all of you?
Yes, ma'am.
Here put a bracket for the last two. Here put a bracket for the first two. That's all. Or anyways, you can put the bracket. There is no rule like, see here, A plus, sorry. Okay, you can put the bracket here, and here you can put the bracket from here to here. That's fine. Now for the next one, write A minus B minus C is not equal to, okay, A minus B minus C. So here maybe you can put a bracket for the first two. Here put a bracket for the last two. That's all. Is it easy or no?
Yes, yes, ma'am. It's easy. It's easy.
Now if you write x, y, z, x minus y minus z not equal to x minus y minus z. So put a bracket maybe for y and z here. Here put a bracket for x and y. That's all. Now for multiplication, when you take three integers a, b, and c, a into b into c is always equal to a into b into c. Now here put a bracket for the first two, here for the last two, like this. So multiplication is always associative. Now division, a divided by b divided by c is equal to a divided by b divided by c. Put a bracket. This will not be the same. So all this we will understand later. So addition is associative on integers. Subtraction is not associative. Multiplication is associative. Division is not associative. Like commutative only. Exactly like commutative property. Commutative, you check on two numbers. Associative on three numbers. Take a picture, children. Oh, sorry, this one you didn't take, right? Just a minute. I'll clear the slide. Yeah, take a picture.
Yes, ma'am. I took it.
All of you? Okay. This is the next one. You should not blindly copy into your notebook, children. You need to read, understand, and then write. Don't blindly write it. A teacher asked to write something, so I finished writing, but I don't know what I wrote. Don't do that. First read, understand, and then write. I've explained everything. See, I'll read the slide for you. I've explained all this. We say that addition is associative for integers. What do we mean by that? That is, for any three integers a, b, and c, a plus b plus c, a plus b plus c is equal to a plus b plus c. Didn't I explain this, children? Didn't I explain this? Why no answer?
Yes, ma'am. Sorry. I was trying to hit the space bar and unmute, but it didn't work.
Now look at this one. We say that subtraction is not associative for integers. What do you mean by that? That is meaning for any three integers a, b, and c, a minus b minus c is not the same as a minus b minus c. Didn't I explain this?
Yes, ma'am.
Same thing. That is what I've written here. Exactly what I told you is here. Or we say that multiplication is associative for integers. That means for any three integers a, b, and c, a into b into c is the same as a into b into c. We say that division is not associative for integers. What do we mean by that? That is, for any three integers a, b, and c, a divided by b divided by c is not the same as a divided by b divided by c. I wrote all this. So the explanation is here. Take a screenshot, children. Done, children?
Ma'am, took, ma'am.
Okay.
Done.
Yeah. Now, the role of zero. Zero is called the additive identity for integers. Zero is called the additive identity for integers. Because any integer plus 0 is the same as 0 plus that integer. What answer will you get for both? You will get A. What is A plus 0? A. What is 0 plus A? A. So for both, you're getting the same answer A. Whether it is A plus 0 or 0 plus A, the answer is A. Identity means identical. Now, supposing you have twin friends, okay? Twin friends. And if you say that the boys are identical, I can't make out between the two boys. They're so identical. That means they look the same. They look the same. You can't make out who's Arun, who's Tarun. You can't make out. You call Arun Tarun, Tarun Arun, because they're so identical. So identity means identical, same, meaning same answer. So when will you get the same answer? Like supposing you take an integer like 5. When will you get 5 itself as the answer? If you add 0 to it, you will get the same answer, identical answer you will get. That is why 0 is called the additive. Why additive? Because when you add. Why identity? Because you're getting the same identical answer. Why identical? Because 5, 5, same answer. 5, 5, identical. That's why it's called that's why 0 is called the additive identity for integers. The additive identity for integers is 0. Because if you take any integer A and add 0 to that, or if you take 0 and add any integer to that, in both the cases, whether it is A plus 0 or 0 plus A, the answer is A itself. So you're getting the same answer. That means,
ma'am, yes, ma'am, 5 plus 0 is 5 and 0 plus 5 is 5 only, ma'am.
Correct. That's why 0 is called the additive identity. Additive because you're adding. Identity because same answer, identical answer. So 0 is called the, you should remember this, 0 is called the additive identity for integers. As means because A plus 0 is equal to 0 plus A is equal to A. That means A plus 0 also answer is A. 0 plus A also answer is A. See now, this will be right. Supposing you get A is equal to 5. I'm saying some other situation. A is 5 and you're getting B also is 5. So you can write A is equal to B is equal to 5. You can write like this. Supposing A is 5 and B is 5. You can write A is equal to B is equal to 5. Similarly here, what is A plus 0? A. What is 0 plus A? A. So for both getting the same answer A. So you can write it as for A plus 0 and 0 plus A. You're getting the same answer, which is A. That's what it is. Whether it is A plus 0 or 0 plus A. For both the answer is A. Like you write A is equal to 10, B is equal to 10. That means A is equal to B is equal to 10. That means both A and B is 10. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now, multiplicative, multiplicative identity. Multiplicative identity. Identity means identical, same answer. Identity, identical answer, same answer. But when you multiply, you want to get the same answer. When you multiply, that is, you take an integer and you multiply it with something and you want to get the same answer. Like you want to take 10. You want to multiply this with something and you want to get 10 only as the answer. Then what is that number? 1. 10 into 1 only is 10. Now you want to take an integer minus 8 and you want to multiply it with something and you want the answer to be minus 8 itself. So you should multiply minus 8 with 1. So 1 is called the multiplicative identity. Multiplicative because on multiplying. Identity because the same answer. So if A is any integer and you multiply it with 1, you get A itself as the answer. Or to 1, if you multiply A, where A is an integer, you will get A itself as the answer. That means whether you multiply A and 1 or you multiply 1 and A, you get the same answer, which is A. Is this understood, children?
Yes, ma'am.
So 1 is called the multiplicative identity for integers because a into 1 is the same as 1 into a is equal to a. Where a is an integer. Who is this a? A is an integer. A is an integer. Understood, children?
Yes, ma'am, understood.
Now, if I just tell you, tell me the contents of the slide. I'll just tell you, in one slide, I had written the roll of 0 and roll of 1. Tell me everything that you saw in that slide. You should be able to say that 0 is called the additive identity for integers because a plus 0 is equal to 0 plus a is equal to a, where a is an integer. And the next one also, you should be able to say like that. Don't just write and leave it. I'll ask you questions. Everything that you learned today should go to your memory. So practice before you come to the next class.
Ma'am.
Yeah.
Okay. Yes, ma'am.
Yeah, children.
Ma'am, screenshot.
No. I have another class now. So you took a screenshot of this one or no, children?
Yes, ma'am.
Ma'am, already did, ma'am.
Okay. Done?
Yeah, ma'am.
Yes, ma'am.
Yeah. Now, children, now till here I've explained. Now I have a class from 7 to 9:30. I have another class. Till here I've explained, but I want you to complete this. Take a screenshot, complete this. But in the next class, I'll explain all this for you. I'll explain all this for you. Yeah, now take a screenshot and complete all this in your notebook. Write it in your notebook. Now this one you cannot understand by yourself. Just write it. I'll explain it in the next class. Yeah, take a picture, children.
I'm already done, ma'am.
This is the next one.
Yeah, ma'am. Next slide.
Yes, ma'am, took it.
Yeah, this is the
Done,
next
ma'am.
one.
Yeah, ma'am.
Understood this? I'm sorry, took a picture of this one?
Yes, ma'am.
Yes, ma'am.
Yeah, next is this.
Yes, ma'am, I took it.
Yes, ma'am. Yes, ma'am.
Yeah.
Yes, ma'am.
That's all, children. That's all.
Okay,
So
ma'am.
complete all this.
Yes,
We'll
ma'am.
understand the
Thank you,
rest.
ma'am.
Yeah, we'll understand the rest in the next class. All right, children. Thank you so much. That's it for today's session. You may leave the call.
Thank you, ma'am. Have a nice day.
Thank you, children. Thank you, children.